Yeah. 11 was false. That's a translation. Excuse me. Hold on. Guys, all those other questions, you can get them off. You can get them online. You can get 1 through 7. 1 through 7 is part 1. 8 through 14, and part of another problem is in 6th period and 7th period. In 7th period, I would like to go through 15 through 20. All right. Number 15 says true or false, the figure has line symmetry. And that's true because it has a line symmetry. It has a bunch of lines of symmetry. There's horizontal symmetry. Here's vertical. And then each of these diagonals here, I could just keep going down through all those middle points right there. And so 1, 2, how many sides? 8 sides? What is that called that has 8 sides? Octagon. So it's true, it has line symmetry, and it has 8 lines of symmetry. It has an octagon. It is an octagon. All right, 16, it says, rotate 90 degrees, the line y equals 2x minus 3 about the point 21, and write the equation of the new line. That's that whole worksheet we did that day, where we have a line of y equals 2x minus 3. Guys, if the equation of a line is y equals 2x minus 3, what is the slope of that line? Here's the slope of this line right here. 2. Okay? So if the slope of this line is 2, what is the slope of the line perpendicular to it? Very good. -1/2. So now what I want to do is I want to find the the equation of the line that has a slope of -1/2 and goes through the point 2, 1. So what you do is you use your point slope formula, which is y minus 1 equals m. That's the that -1/2 right there. -1/2.
Why did you make it negative?
Okay, because I'll get to that in just a second. X minus 2. I made it negative because the way you find the difference between parallel slope and perpendicular slope, parallel lines have the same slope, perpendicular lines have negative reciprocal slope. Okay, you have to do 2 things to it. You have to find the negative of it, and you have to find the reciprocal. So your question was, how did I go from 2 to -1/2? Well, 2 is positive. If I want to find the negative of a positive number, I have to make it negative. If I want to find the reciprocal of the number 2 over 1, if you will, then I have to flip that number. So it's not enough just to flip it. And not only do you have to flip it, but you have to take the opposite. So now I want to take this equation right here and solve for y. So -1/2, I forgot my x in there. -1/2 times x is -1/2 x. -1/2 times -2, and negative times a negative is a positive 1. So I add 1 to the other side, and -1/2 x plus 2. Now, guys, again, this is one of the things I talked about yesterday in trying to get you to understand there is absolutely nothing wrong with making a mistake in math. You just have to be conscientious enough to check it. Guys, if this is your new equation right here, then this point should work when you plug it in there. So when I take the point 2, 1 and plug it in, -1/2 of 2, y equals -1/2 times 2. That's what that means. And then plus 2 gives you -1 plus 2 is 1. So 1 equals 1. So the fact that 2, 1 works this new equation, and they have negative reciprocal slopes, that means this line right here, and my original line up here, these 2 guys are perpendicular. 17, given the pre-image has the points -2, 3, and B, so I need to come down here and I need to plug in my -2, 3, and my B of -5, 3, and my C of -5, 6. Find the points of the image after a rotation of 180 degrees. Again, 180-degree rotation means that I'm going to take these numbers right here and I'm going to take the opposite of both of them. So this is going to go to 2, -3. This is going to go to 5, -3. This is going to go to 5, -6. And then a reflection over the x-axis. To reflect something over the x-axis, remember we said that the x's will stay the same when you flip it over the x-axis, and the y will become the opposite. So that would be 3, 3, and 6. So this point that started out in the third quadrant, after a 180-degree rotation and a flip, it looks like it's all in the first quadrant. And then all I did was I just applied the rule of a rotation. A rotation of 180 degrees. That just puts it on the other side and makes it opposite. And then a reflection over the x-axis. That's how you reflect something across the x-axis. How many answers is this problem going to have? 2. Guys, when people finally realize this, and I can see it. As a teacher, you see students working problems, and then all of a sudden one day you realize that it's finally hit them. Oh gosh, here's how you work that. Guys, if y'all walked in the door today and on the board it said 5 plus 10x equals -95, and on the board it said 5 plus 10x equals positive 95. If there was some way that I could get you to come in here and say, okay guys, come in and sit down. Here's a 2-question quiz. Take it and see what you do on it. Guys, that's all this is you have to understand as a mathematician, when you have an absolute value problem, there are 2 values that cause this equation to be true. This in here can either be -95 like on the left, and so 10x equals -100, divide both sides by 10, and x equals -10, or 10x is equal to 90. If 10x is equal to 90, then x is 9. And so this thing has 2 solutions. Here's what gives me -95. -10 gives me -95. But then what's the absolute value of a -95? 95. Over here, x equals 9. When I plug a 9 right there, I get 90 plus 5. That gives me positive 95. So this positive 95 has an absolute value of 95 also. And so there are 2 solutions to this problem. Positive 95, or positive 9, and -10. Now, what that does is it takes us to the next type problem. It takes us to absolute value inequalities. Earlier today, during the 6th period, I saw this 10n plus 2 is greater than 92. As I solved that problem right there earlier. If you need to see what the answer is, it's n is less than -9.4, n is greater than 9. If you have a specific question about that answer, I'll answer it here in just a second. But one of the things that I did was I compared it, eyes up here, is I compared it to this problem right here. Because when I was working this, before y'all came in, there used to be some red, there was some writing right here in the middle, and it talked about less than. I erased that so you guys come in and you don't know that it's not there, because I did the same thing for them that I'm going to do for you in just a second. Because if this problem is less than, the way you work it is you write 2x plus 2 less than 18. Then over here on the left, you go greater than -18. You just keep these symbols both pointing left. If this same exact problem was sitting over here and it had greater than in it, then you would go 2x plus 2 is less than or equal to negative 18, or 2x plus 2 is greater than or equal to 18. Guys, all because of the original problem. So once you determine whether your final answer is going to have the word or in it, or the word and in it, that's how you know when to start the problem. So I'm going to subtract 2. That's going to give me negative 20 is less than or equal to 2x is less than or equal to 16. Finally, I'll divide by 2. I'll divide everything by 2 and get negative 10 is less than or equal to x is less than or equal to 8. Earlier in the week, I described this, guys, as being the banks of a river. As this is the water. Negative 10x, that's the water in there. The banks kind of keep those values closed in. That's when it's or, it's outside, not the water. Everything out here. On the left over here, when it's n is less than or equal to negative 9.9 or greater than or equal to 9, that's talking about the creek here, the river cannot be where your solutions are. The other way of writing that is like this. And when you write it like this, it's like negative 10 is a boundary. It stops. It can't be bigger than 8. It stops over there. And so all your solutions are there in the middle where the water is. So that's kind of how the word less than and greater work. What number is this? 19 or 20? Oh, yeah. 20 is systems of equations. Shoot. All right. Guys, I'm going to solve this problem both ways. I'm going to solve it by substitution, and I'm going to solve it by elimination. Could I solve it another way? Yeah, I could solve it by graphing. Mathematically, you can solve it by substitution, elimination, graphing. Hopefully, some of you will eventually get solving systems using matrices. They use a rule called Cramer's rule. Really quick way to solve it. You guys, just entirely up to you. If you're going to solve it by substitution, the first thing you have to do is you have to take one of the equations and solve it for one of its variables. I chose to solve the second equation for y because it's the one that doesn't have a coefficient, so it'll be pretty much finished after you do that 7x plus 14. So now what you want to do is you want to go negative 14x minus 6, and you want to replace that 7x plus 14 down here for y. So up in the top of this problem, it used to say negative 14x, just like it does down there, minus 6y equals negative 28. So I took out the y and replaced it with 7x plus 14. So negative 14x minus 42x, negative 6 times 4, what is that, negative 84? So minus 84 equals negative 28. So this gives me negative 56x equals, add 84 to the other side, that gives me 56. So x equals negative 1. I add 84. 84 minus 28 is 56. So then I take that x equals negative 1, plug it in right here. 7 times negative 1 plus 14 is negative 7. And again, one of the major points that we talked about yesterday is we now know that these 2 points cross at negative 1, negative 7. Now, if I've done this one right, when I solve it by elimination, should I get the same answer or a different answer? Okay. So let's take it real quick. So I need to kind of organize this up over here and get it straightened away. So I want to see what it is, the least amount of work I can do to eliminate some stuff. So I take negative 14x minus 6y equals 28, and know that if I multiply this bottom equation by 6, and that gives me negative 42x, it gives me positive 6y, and then gives me 60, 6 times 14 is 84. And so I add them, negative 56x equals 56. So again, x is negative 1, just like I got before. So now I can take this negative 1, plug it into either equation. To me, it looks like the easiest equation might be to plug it into negative 7x here. So negative 7 times 7 is 7x, plus y equals 14. So y is 7. Oh, where have I got a negative? I got a negative mistake somewhere. Right here, I got negative 7 plus 14. I should have got positive 7. Sorry about that. So my mistake there was not checking it. And so it should be negative 1 and positive 7. And I would have caught that if I checked it. So that's what I would kind of try to get you to see yesterday. Yeah. Yeah.